Level 0, EF0 tornado, 65 to 85 miles per hour winds. At this level, tornadoes are often called weak. They may break branches, peel shingles from rooftops, and push small outdoor items across a yard. The damage is visible, though it rarely threatens lives directly. Most EF0 tornadoes pass quickly, leaving behind a trail of inconvenience rather than tragedy. A few garden sheds overturned, some broken windows, and maybe a small tree uprooted. These are the tornadoes that many people mistake for strong winds rather than a true funnel. The death count here is virtually zero. People may suffer minor injuries from flying debris or collapsing light structures. In the United States, where thousands of tornadoes have been documented, EF0 events make up the largest portion and almost never make headlines. Think of them as nature's warnings, a reminder of the power that can grow if conditions intensify. For meteorologists, these storms act as signals. They show that the atmosphere has begun to rotate and that larger systems might evolve if instability increases. For residents, they are often an introduction to tornado safety drills and the importance of sheltering, even when the storm seems small. The science behind the storm, EF0 tornadoes often form from short-lived, rotating thunderstorms that lack the intense, organized updrafts of their stronger cousins. They can occur in many environments, even on the fringes of major storm systems. Level 1, EF1 tornado, 86 to 110 miles per hour winds. These weak vortices are like the faint handwriting of the atmosphere, hints of what might emerge if conditions sharpen. This level begins to show the danger. Roofs can be stripped away, mobile homes overturned, and cars pushed off roads. Power lines may snap and small barns or weakly built structures can collapse. The death count remains low, though no longer negligible. A poorly anchored mobile home can become deadly in EF1 winds. In rural areas, residents often survive by sheltering in basements or storm cellars. In communities without such protection, the risk rises. In 2018, an EF1 tornado struck near Land O'Lakes, Florida. It tore apart mobile homes and injured residents, though no deaths were recorded. Stories like this remind us that while EF1 tornadoes are not catastrophic, they demand respect. EF1 tornadoes are often remembered locally rather than nationally. They disrupt lives, scatter belongings, and can displace families for weeks. The difference between an EF0 and EF1 is striking, as the winds become strong enough to challenge human structures in a very real way. For communities already vulnerable, the consequences can linger long after the funnel has passed. The science behind the storm. These tornadoes require more sustained rotation within a thunderstorm's updraft. They are common in both discrete supercell thunderstorms and within larger lines of storms known as squall lines. Their formation shows how a storm has organized itself more completely, with enough vertical wind shear to sustain stronger and more damaging winds. Level 2, EF2 tornado, 111 to 135 miles per hour winds. Now the destruction grows severe. Entire roofs can be lifted from houses, large trees uprooted, and vehicles flipped. Masonry walls may crumble. At this stage, the tornado is strong enough to turn deadly. The death count at EF2 often rises when people are caught in cars, mobile homes, or poorly built houses. Survivors frequently describe these storms as sounding like roaring freight trains. The psychological impact is almost as devastating as the physical destruction, with families recalling moments of terror as walls shook and glass shattered. One tragic example occurred in 2013 when an EF2 tornado struck Hood County, Texas. It destroyed dozens of homes and killed 6 people. This marked a turning point in the community's understanding of preparedness. EF2 storms are not background weather events. They reshape lives and neighborhoods. The scars left behind by EF2 tornadoes can take years to heal. Insurance claims pile up, schools and businesses close temporarily, and families face the challenge of rebuilding while coping with loss. At this stage, the power of nature is undeniable, and respect for warnings becomes essential for survival. The science behind the storm. EF2. Intensity signifies a strong, stable rotation connecting the thunderstorm to the ground. This requires significant wind shear, changes in wind speed and direction with height, to create the necessary spin in the atmosphere. Meteorologists monitor these ingredients carefully, as once an EF2 is reached, the storm has proven its ability to sustain violence. Level 3, EF3 tornado, 136 to 165 miles per hour winds. EF3 tornadoes mark a leap into catastrophic territory. Well-constructed homes can be torn apart, steel frames twisted, and entire forests shredded into splinters. Cars and trucks are no longer just pushed aside, they are thrown through the air. Fatalities become common. The death count rises significantly as structures that once seemed safe collapse. Towns that face EF3 events often speak of landscapes that no longer resemble their own. The destruction is wide, severe, and often heartbreaking. In 2020, an EF3 tornado ripped through Nashville, Tennessee. It leveled homes, tossed power lines across streets, and killed 25 people. The devastation stunned residents who woke up to a city transformed overnight. These tornadoes dominate national news and bring waves of volunteers, donations, and emergency responders. Survivors frequently describe waking up in shelters or hospitals, struggling to recognize the neighborhoods they once knew. EF3 tornadoes are no longer survivable without a sturdy shelter. The science behind the storm. This intensity is almost exclusively the product of a powerful supercell thunderstorm. These long-lived storms have a deep, persistent rotating updraft called a mesocyclone, which acts as the engine for strong tornadoes. When atmospheric instability is extreme, EF3 strength becomes not only possible but likely. Level 4 EF4 tornado, 166 to 200 miles per hour winds. Here we enter the realm of devastation few can imagine. EF4 tornadoes do not simply damage structures, they erase them. Homes are reduced to piles of rubble. Entire subdivisions vanish, leaving only concrete foundations. The death count here is often measured in dozens. Even people in sturdy homes may not survive unless they shelter underground. Cars become deadly missiles hurled blocks away from their original positions. One of the most chilling examples is the 2011 Tuscaloosa-Birmingham tornado in Alabama. Classified as EF4, it destroyed thousands of homes and killed more than 60 people. Hospitals overflowed with the injured. Survivors recalled streets lined with nothing recognizable. At EF4, the tornado is no longer a local storm. It is a disaster of regional impact. Relief efforts stretch across states. Economies are disrupted, and entire school districts may be displaced. The recovery process can last for years, sometimes reshaping communities permanently. The science behind the storm. EF4 tornadoes are the result of a perfectly organized supercell in an extremely volatile environment. Exceptionally strong instability and wind shear combine to create a violent, wide vortex that can maintain its strength for dozens of miles. Level 5 EF5 tornado, over 200 miles per hour winds. This is the maximum of the scale and the rarest event. EF5 tornadoes are nature's most violent windstorms. Well-built houses are swept completely away, leaving bare ground. Steel-reinforced concrete structures can suffer severe damage. Trees are not just uprooted, they are stripped of bark. Vehicles become unrecognizable fragments scattered far from their origin. The death count at this level can climb into the hundreds depending on population density. These tornadoes rewrite history for the communities they strike. Survivors often describe scenes that resemble war zones. Psychological trauma runs deep as the scale of loss is overwhelming. The 2011 Joplin, Missouri tornado was an EF5. It directly killed 158 people, making it the deadliest single tornado in modern U.S. history. The destruction was beyond comprehension. A hospital was heavily damaged, entire neighborhoods flattened, and debris scattered miles away. Rescue workers described it as one of the most challenging missions of their careers. EF5 tornadoes are so powerful that scientists study their paths for decades. They represent the very edge of atmospheric violence on Earth. Communities that experience them never forget. The storms are written into collective memory, shaping generations. The science behind the storm. The EF5 represents a worst-case scenario where every atmospheric ingredient, moisture, instability, lift, and extreme wind shear, is maximized. The tornado's vortex is so intense and low pressure that it literally scours the Earth, creating a signature of utter annihilation. No engineering standard is truly designed for winds of this strength. If you feel this journey gave you a clearer perspective on tornadoes, you can share it with others who might benefit from knowledge over fear. Write in the comments, I choose clarity over chaos.